BIM data's importance within architectural practices is exponentially growing. We are heavily reliant on BIM data. It is safe to say that for a firm to prosper in the future, they must master the creation, organization, analysis, and extraction of BIM data. However, that is not the case. So often during workflows, projects are transferred to other softwares to perform tasks such as solar analysis or compliance checking. And during this transfer, valuable BIM data is either lost or discarded due to issues of interoperability. This is not good, for it takes designers' efforts away from designing to instead focus on menial technical issues. This situation ultimately results in a less effective work, money and time that is wasted for the firm, and a worse built environment for us to inhabit. Therefore, we seek to use machine learning to create interoperable BIM data in response to this issue within the workflow. This project is concerned with understanding machine learning's place within the architectural practice. So we have focused our efforts to testing, firstly, whether machine learning algorithm is capable of understanding floor plans. This is accomplished through the training of a convolutional neural network to read floor plan images, which will go on to inform an automated labeling application. And so the end product of this research will be a convolutional neural network that automatically defines and labels room elements through a method known as instance segmentation, producing a prediction, which is a classification of a room, e.g. bedroom, bathroom, kitchen, a segmentation mask, which is a definition of the room's area, and a boundary box, which lists the coordinates of the room. Ultimately, this will be universal data that is automatically created, and so can be applied for the improvement of architectural workflows, and in so proving the reliability of machine learning in the architectural workplace. So how does a machine learn? Well, firstly, a massive data set with labels is produced. Labels are correct outputs that are prefabricated. These are then fed into the neural network, each image at a time. And the neural network produces a prediction, and then it assesses itself against the label. And through back propagation, it adjusts itself to improve, and then repeats this process, continually trying to improve itself to be more correct to the label. And by the end of the training process, we should have a neural network that could receive a new floor plan image that has never seen before during its training and correctly label it. So this is our workflow within our project. A training data set of varied floor plan images of topologies, scales, types, and drawing styles is compiled, and adjoining labels are produced, and then fed into the neural network to teach it. We then export this knowledge to be applied to a script which reads new floor plans and produces an instant segmentation on them. And so within our limited training of about 400 to 500 images, we have already seen that yes, in fact, a machine can understand floor plans, at least. We believe that there are various elements the convolutional neural network is picking up on to create its assessment on each room instance. These include feature detection. These could be elements such as words, symbols, and icons. If we look at bedrooms, there are common symbols within there. Obviously the bed, or the bathroom, the common symbol of a toilet. Then we have line work, which could be things such as walls, and when we have clear room distinctions, and also things such as floor patterns. If we think about the bathroom, they have tiled floors, so we see that checker mark on the floor plan. Or on a balcony, there's often the wood deck. This is also distinguished. And another one would be relationships. So where the floor plan has very little visual information to be seen, uh, non-visual architectural information may be extrapolated. This relational information. These are common design principles such as room shapes and sizes, orientation, and their relation to each other. Such as the living rooms are the largest open space typically within a house or an apartment. A bathroom would never be connected onto a balcony. These are sort of fundamental design concepts, and we can see in our results that it is picking up on these. So therefore, let us understand through this single image of a bathroom what the convolutional neural network may be seeing. Well, firstly, it could be seeing these icons of toilets, a bath, a sink, a shower, and it could be saying that then, okay, so this space here is a bathroom, and then it's further validating itself by seeing that it's a small room, it's narrow, it has a tiled floor pattern, and it is surrounded by thick lines. So it could be saying then pretty confidently that this is a bathroom. And it could also be seeing, you know, we have bathrooms on average being close to bedrooms. This could then be further backing it up, and it could be confidently predicting this space that we see here as a bathroom. So this research has very much been the first steps on this subject, very much the primary knowledge.